going to act as the chair for today's session. My name is James Lindsay. There will be 2 talks, each one slated for 20 minutes. To each speaker, we'll first hear from Mark Hogan and then from Osbert Pang. To the 2 speakers, I will just give you a 2-minute warning when you have 2 minutes left in your talk. It looks like we have a little over an hour scheduled, 10:10 to 11:15. So maybe each speaker can have an extra moment, and there'll certainly be some time for some questions. So without further ado, Mark, are you here? You may take over.
Yes, thank you very much, James. I'll just share my screen. Okay, great. Has that come through okay, James?
I can see and hear. Everything seems to be working great. Take it away.
Great, thank you. Firstly, thank you to the organisers for arranging this nice event. I'm Mark Hogan, Head of Time Series Analysis Branch in the Office for National Statistics. This presentation is on an interesting divergence I noticed between indirect and direct adjustments for a business area I was helping when they were using the contribution to growth method. I'll preface this by saying that there isn't anything particularly complex happening here. It turned out to be a rather simple issue, but I thought this may be interesting to the audience and hopefully serve as a cautionary tale. So the issue was, I was asked by a business area to help them decide whether to use indirect or direct adjustments. So as an example here, I had one of their series and I did the usual analysis of applying direct adjustments here in light blue, then indirect adjustments in dark blue, and checking for revisions and residual seasonality. There was no concern in terms of revisions or residual seasonality, and so I recommended they use the indirect method. I was surprised, therefore, when the business area said they were concerned about a divergence they noticed once they'd processed the time series. So I asked for their results, and I was quite surprised when they gave me this series, which shows a persistent and growing divergence between their indirectly adjusted series and mine. Before I go any further, I'll explain a bit more about the contribution to growth method. This is a method the business area uses to create an index from components. So to keep things simple, if we assume we have one series T, which is simply the sum of the components A and B. We first calculate the percentage growths for each of the component series, and then we calculate the weights. In this case, it's the value of that component as a percentage of the total in the previous time period. We then multiply the growths and the weights to get the contribution to growth from each component, and we can sum them to get the total contribution to growth, and we can use that to form an index. So that's the growths, the weights, that gives us a contribution to growth, and then we aggregate to get the index. My first question when I was researching this was whether there was something peculiar with the particular seasonal adjustment models I was using. So I simply applied a very simple set of moving averages to some simulated data, but I found that the divergence still occurred when I applied the contribution to growth method with seasonal adjustments. I then thought maybe it may be something to do with the indices. I know the Eurostat guidance mentions a known issue with L'Espèce type chain-linked indices. And so instead of doing this for the indices, I did it for the underlying CVM series. But again, the divergence was present. I then began to wonder whether there was something curious happening with the specific data, and so I simulated several data sets and applied these methods, seasonal adjustment and contribution to growth. But for each of the simulations, this divergence still occurred. This led me to my next question, which was whether this is something caused by seasonal adjustment in its own right. And so what I did next was I applied the contribution to growth method as the business area was using it, but straight away to the non-seasonally adjusted series. And this was quite telling because it showed that I get the same divergence even when I apply the contribution to growth method directly to the non-seasonally adjusted series. So my final research question was then whether this is being caused by the contribution to growth method. So I applied seasonal adjustment as I did before, but without the contribution to growth, and there was no divergence. So, I sought some help and advice from international colleagues, and if any of them are present, thank you very much for your help and advice. And from that, I delved into the algebra. I'll present a simplified version here for the presentation. So we'll assume that there's one series T, which is the aggregate of A and B. The growth for component A at time point T is the change in that component as a proportion of its previous value, all very straightforward. And the weight that I will refer to as the true weight is the value of the component in the previous period as a proportion of the total in the previous period. After liaising with the business area, I discovered that what they were actually using was annual weights. I apologise for my notation, it's rather inelegant here, but essentially they were calculating the annual sum of component A, using that as a proportion of the annual sum of the total. And obviously the true weight and the annual weight are only equal under quite strict constraints which are unlikely to hold in practice in general. But you can write the annual weight as the true weight plus this term, which I'll refer to as a discrepancy. And so when they next calculated the contribution to growth, the true contribution to growth is again just the growth multiplied by the weight. But as they were using the annual weight, they were getting this true contribution to growth plus this discrepancy term. So you can see how this discrepancy from using annual weight is starting to propagate through the calculations. When this is applied at the total level, again, the true contribution to growth in the composite is just the sum of the component contributions to growth. But when you use the annual weight, this can be written as you can see on screen. And I've circled here the discrepancy, and you get a discrepancy from each of the components. So this discrepancy because of the weight is starting to aggregate across the components. For brevity, I'll refer to this discrepancy as D subscript T. And the total index at time point T, when you use annual weights, is equal to the value in the previous period multiplied by 1 plus this C tilde. And that can be written as 1 plus the true contribution to growth plus the discrepancy for time point T. And this compounds over time because the index value at time point T minus 2 can be written as this multiplication factor, 1 plus CTT plus DT, and an additional similar factor. So you can see now how this effect is starting to compound over time. So at this point, I was fairly satisfied that I'd found the cause of the issue. They're essentially taking annual weights calculated from non-seasonally adjusted data and applying them to quarterly seasonally adjusted data. And the way they use it is compounding this discrepancy over time. I considered some possible solutions for this for the business area. One was simply to do nothing, which is unacceptable because of this alarming divergence between the seasonally adjusted and the non-seasonally adjusted series. A colleague questioned whether benchmarking could be used to remedy this. I felt that may not be a good solution, but I pursued it nonetheless, so I would have some objective evidence for my recommendation. So I applied 3 different kinds of benchmarking. On the screen, you can see the non-seasonally adjusted series in grey. In red, you can see the seasonally adjusted with contribution to growth, but pre-benchmarking with this large divergence. And in red, yellow and orange, you can see the various benchmarking methods I used. Now, if you look at those benchmarking series, you may think that benchmarking has done quite a good job because the benchmarked series seem to cut through the peaks and troughs of the non-seasonally adjusted series. However, if you look at the growth rates of these series, it's a little bit difficult to see from this chart. So what I've done on the next chart is I've looked at the difference in the growth rates from the benchmark series compared to the pre-benchmark series to better see how it's maintained the growth rates. The green line on screen is from the pro rata method, and it you may feel it's done a good job because it's a very flat series along 0, suggesting it's maintained the growth rates quite well. However, you'll notice there's some regular peaks, some of them getting really quite large, and these always appear in Q1, which is a known problem with the pro rata method, and it's one of the reasons I believe it's specifically advised against in some international guidance. The Denton and Gillette-de-Gum method seem to do a bit better, but again, towards the end of the series, they're making quite large adjustments. And international guidance in the area reminds us that the assumption behind benchmarking is we're just making small adjustments, ideally less than 5% and certainly no more than 10%. And any larger discrepancies suggest that there's something systematically wrong that needs to be addressed. So for this reason, I recommended we don't use benchmarking as it would treat the symptoms, not the cause, and that it would be making increasingly large adjustments because the divergence would be getting larger and larger. The other 2 methods were to simply stop using the contribution to growth method, and one of those is to stop using the indices as well and just use and publish the underlying CVM series, chained volume measure. This would get rid of the cause of the divergence. However, this CTG method is deeply embedded into the production process of this business area, so it would be a substantial change, and that's something they're currently thinking about and working through. And finally, for completeness, I considered they could simply just use direct seasonal adjustments right at the end. However, this wouldn't remove the divergence because the business area would still be using the contribution to growth method. And there was concern about a lack of additivity, as there often is between direct and indirect adjustments. However, the data sources for this production area are quite complex. They have one data source for their total, another one for the components, and they don't perfectly align. They're a chained volume measure series, which is known to not be perfectly additive. And while they do publish the indices, they don't publish the weights, so users can't replicate the additivity. This is currently with the business area for consideration as to what to do. But again, I'll thank international colleagues who provided some advice on this. And as I said at the start, this wasn't a particularly complex issue as it turned out, but hopefully nonetheless this has been interesting and will serve as a cautionary tale for anyone who comes across this method in the future. Thank you very much. I'll pause there for any questions or comments. Over to you, James.
No, thank you very much. Very nice talk. There are some questions in the chat. Mark, are you able to see the chat? I can read them.
Yes, I can. Thank you. So I see the first one's from Dario. What would happen if instead of the contribution to growth, you'd used delta logs to compute the growths? Have you tried to force multiplicative decomposition? So to answer your question, Dario, I don't believe the business area have considered that, but I'll certainly pass that across. And I think as long as it would avoid them using annual non-seasonally adjusted weight and applying them to quarterly seasonally adjusted data, that may be a good solution. And Dario also mentions how I consider the Marini Defonso method for benchmarking. I haven't actually, Dario, but thank you for making me aware of that. I'll be sure to look into that, and I'll make a note as well.
And I believe somebody had their hand up. Is Dario? Would you like to unmute and ask a question?
Yeah, so thank you for your presentation, and especially for quoting the guidelines on template aggregation, of which I'm one of the co-authors. Actually, with Duncan, we coordinate the full work. So, I mean, the benchmarking options you have considered are the pro rata is something that we'd never recommend. So also for your testing, that's not really. So whatever regression method would make sense to me. So this in this Marini Defonso paper that I'm sure you can find, there is also an approach which is based on structural time series. So you solve the problem from the beginning, so at the source, because they deal with seasonal adjustment and benchmarking at the same time in a unique GLS framework, if I remember well. That's their solution. So I really invite you to have a look into that. In terms of references, at Eurostat, we also have the handbook on quarterly national accounts, where you can find some other solution. And I don't know if Anna's mic is connected, but actually in GeoMetra Plus, we have a couple of plugins that you might want to use for template aggregation and benchmarking. And I could point you those plugins to you on GitHub if there is an interest.
Oh, yes, definitely, Dario. I'd welcome those references, please. Thank you.
You also have the R package by the Swiss guy, which is called Temp Desag. It's an R package called Temp Desag.
Yes, I believe it may have been either there's another package or it was extended by, I think it was Luke Mosley at Lancaster University as well. So yes, there's a few other options for me to think about with benchmarking, but I think your idea about the delta logs, that may solve the problem at source, hopefully.
Reference is the benchmarking plugin that you can find in GeoMetra Plus that you might want to use. Great presentation. Thank you very much.
Thank you very much, Dario. Are there any other questions from people? Feel free to unmute, raise your hand. All right, Mark, thank you very much. I also enjoyed the talk, and I will turn it over to Osbert Pang for his